Okay, so today we're going to be talking about a special right triangle. And people have asked me, like, what do you mean a special right triangle? Well, the deal is that as you get older and you learn trigonometry, we are going to be writing the ratios of the sides of right triangles. And there are some more lovely and less lovely triangles that we could write the ratios. And so I'm going to teach you two really quite lovely triangles that we're going to be using over the next however long you do trigonometry, and whether it's through calculus, et cetera, et cetera. So the first one is if you take a square. Okay, so an isosceles right triangle. So half of a square is an isosceles right triangle. And so I'm going to take this and be like, okay, here we go. Take half of a square. You know a square has a right angle. You can hear my cat getting a little snack behind us, chomping on our cat food. But that's the munching you hear behind. So the deal is that if you've got a right triangle, you know the two legs are the same side and the hypotenuse will be a little bit longer. Okay, and so if you try this and be like, well, what if the legs are both 3? Okay, let's see if we can see any patterns, because there's absolutely a beautiful pattern and we're going to capitalize on it so that we can so easily find missing sides on a right triangle, an isosceles right triangle. So first of all, we know both these angles are going to be 45 degrees. Because they're isosceles, and then the right angle is going to be 90. Okay, so if you do 3 squared plus 3 squared, you're going to get the hypotenuse squared. Okay, so you 9 plus 9, you get x squared. That's 18 equals x squared. If you want to find the hypotenuse, you square root it. Square root of 18 is irrational, but it breaks up into 9 and 3. All right, so the hypotenuse would be square root of 18, which would be 9 root 2. Let me fix that. 9 root 2. And so square root of 9, square root of 2, so it would be 3 root 2. So notice square root of 3 times the square root of 2. Well, square root of 2 is like 1 point stuff. And so if you want to figure out what exactly 3 square root of 2 is, you can put your calculator 3 times the square root of 2. And you get like 4.2-ish. Okay, so it's a little bit longer than the legs, but it has to be longer because it's the hypotenuse. And so the first question that we're going to actually do is going to say, let's establish like the common ratio. Okay, if we do it in terms of x, let's do it abstractly. We're going to do x squared plus x squared equals, we'll call this c, the hypotenuse squared. So x squared plus x squared is 2x squared equals c squared. And then if we want to get plain old c, we're going to square root both sides. So c is equal to the square root of 2x squared. And so that breaks into the square root of 2 times the square root of x squared. The square root of x squared is just x. So c is equal to x times the square root of 2. Now here is the golden ratio, okay? If the legs are both the same, okay, because it's isosceles, the hypotenuse will be longer than each of those legs by a factor of the square root of 2. So if the legs are each x, then the hypotenuse will be x square root of 2. So this is the special ratio, x and x and x root 2. And so that's going to help us, okay? And so anytime we have an isosceles right triangle, that is actually the case. And if you don't believe me, do the Pythagorean theorem every single time, and you'll get the same answer. So the Pythagorean theorem would be kind of the longer method, but it actually would work. So it's kind of up to you what you want to do. So they're saying, okay, let's try it. If FE is 6, can you find the other two sides? Well, the truth is, if this is 6 and this is 6, okay, because it's isosceles, do you know what the hypotenuse will be? Well, it's going to be 6 root 2. Well, if you don't believe me, try it. Do 6 squared plus 6 squared and see what you get for x squared. It's going to be 36 plus 36 is 72. The square root of 72 is going to be square root of 36 times the square root of 2, or 6 root 2. Hey, it is it. So that ratio holds in this next question. Okay, so again, you can do the Pythagorean theorem, but you don't have to if you know the code. Okay, so okay, let's try the next one. If FE, pardon me, is going to be 3 squared of 6. That's 3 squared of 6 if you have an isosceles right triangle, we know both legs will be 3 square root of 6. What would the hypotenuse be? Well, could you do the Pythagorean theorem? Yes. Okay. You could take 3 squared of 6 squared plus 3 squared of 6 squared and see what you get and take the square root. That would be 6 times 3 is 18. Or no, 9 times 6 is 54. Okay, pardon me. So this would be 54 plus 3 squared and square root of 6 squared would be another 54. That'd be 108 is equal to x squared. If you break it down, you're going to get, lo and behold, let me see what we're going to get. Square root of 36 times 3. Square root of 36, square root of 3, or 6 root 3. Wait a minute. That looks kind of weird, doesn't it? Well, let's look at this. Remember, the formula says if these are each x, okay, this is going to be, so the ratio is x, and x root 2. Okay, and so x root 2, notice if I take x, which is 3 squared of 6, and times it by the square root of 2, I'm going to get 3 root 12. Okay, so 3 root 12 breaks into the square root of 4. Oopsie, I need a pen. The square root of 4 and 3. So square root of 4 is 2. 2 times 3 is 6, or 6 root 3. So literally, you can do the Pythagorean theorem. You can. But if you know the code of an isosceles right triangle, you know the two sides are x, or the same value, and the hypotenuse is that the leg times the square root of 2. Okay, and so let's think about working backwards as well. Okay, and there's a couple ways to do this. I'll walk it through like slowly and see if you guys can see, what makes the most sense. Now they're giving us EG is 5 root 2. Okay, so this is 5 root 2, and they're like, ooh, what would be the sides? Okay, here we go. Well, if you know this side is going to be x, and this side is going to be x, and this equals x root 2, you could actually solve that equation by dividing both sides by the square root of 2, and you get x equals 5. Okay, and so you know each of these sides has to be 5. Now, on the other hand, you can kind of see this. Hey, the legs have to be shorter than the hypotenuse, and they're going to be 5, 5, and 5 root 2. It's you multiply by the square root of 2 to get from the legs to the hypotenuse. Technically, you divide by the square root of 2 to get from the hypotenuse to the legs. Okay, so there is that factor. And so I feel like kids do better when they see an equation and they solve it. So if you write the ratios on there, so x, and x root 2, and solve the equation for x, and then place it, use that to find the other missing sides. And so that's kind of the method I'm going to show you guys. If you see a slightly faster shortcut, you certainly can use it, but that's what I'm going to show you for you guys. So EG is going to be 12. Now, where does EG live? EG is the hypotenuse. So if EG is the 12, okay, so let's talk about this. If EG is the 12, and we've got to find the other two sides. Okay, so I'm going to call, instead of calling them, well, we can call that. So x, and x root 2. Okay, and so we've got to figure out what would the hypotenuse be, or what would be the legs. Okay, so if we solve this equation, we're going to find the value of x, which is going to be the other two things. Okay, so we're going to divide both sides by the square root of 2. And so you end up with 12 squared over the square root of 2. Now, that's the answer, but let's rationalize it. So if we times top and bottom by the square root of 2, you're going to get 12 square root of 2 over 2, or 6 root 2. So that means your x value is 6 root 2. That means these two sides are 6 root 2. Let's check it. If I take 6 root 2 and I times it by the square root of 2 to get to the hypotenuse, I get 6 times the square root of 4, which is 6 times 2. Yeah, I do get 12 to be the hypotenuse. So our final answer will be the hypotenuse is still 12, and each of these legs is 6 root 2. And the legs have to be the same size in an isosceles triangle, and the hypotenuse has to be longer, okay? And the factor is related by the square root of 2. So to get from the legs to the hypotenuse, you times by the square root of 2. And so that does make this true here. Okay, let's check out the next one. If EG is 9, find the other two sides. So EG, oh, that's the hypotenuse. Okay, so let's try this. So if EG is 9, we've got to find the two legs. Okay, and so let's write on the ratios here. So if this side is x, and this side is x, and this is equal to x root 2, Okay, so the two sides are the smallest. Those would be 1x and 1x, and the hypotenuse is x times the square root of 2, or a little bit bigger, because the square root of 2 is just really 1 point stuff. So if you take x and times it by a little bit bigger, it'll make a bigger number. So the ratio holds. Okay, the two legs are smaller. They're 1x, 1x, and x root 2. The hypotenuse will be the longest side. So in order to find out what x is, which would be the two legs, we have to solve that equation. So if we take 9 equals x root 2, to solve for x, we're going to divide both sides by the square root of 2. Okay, divide by square root of 2. 9 over the square root of 2 is the answer, but we're going to rationalize it. You get 9 root 2 over 2. And that's what x is, and that's what these other two sides would be. It would be 9 root 2 over 2. Okay, so if you want to check your work and be like, okay, if I take the leg, 9 square root of 2 over 2, and if I want to times it by the square root of 2 to see, do I get the hypotenuse? You get 9 times, well, the square root of 2 times square root of 2 is 2. That'd be 18 divided by 2, which would be 9. Okay, and so the situation holds, but you don't have to check that. But the legs are as shown, and the hypotenuse is 9. Now, another factor, if you're thinking about this and you want to be a little tricky, you can. Some people take a leg's, if I give you the leg length, you times it by the square root of 2 to get the hypotenuse. Some people do the divide to get to the legs. And if you want to say that you want to divide by the square root of 2, okay? If this dividing by the square root of 2 is the same as multiplying by a certain factor. So I'll give you an equivalent factor. If you times this by the square root of 2 over the square root of 2, you get the square root of 2 over 2. So if you want to do this all in one step, okay, and if I give you the hypotenuse and you're like, I want to divide by the square root of 2 to get to the legs, you can instead take any hypotenuse. So like if you look at example 5 here, okay, if I want to divide by the square root of 2 to get to the legs, instead of just dividing by the square root of 2, I can just times it by the square root of 2 over 2, and I'll get the exact same answer. Look at this. 2 goes into 12 6 times. I get 6 root 2. So that is a faster way to get to it, to be like, hey, I want to times by the legs to get to the hypotenuse. We'll times it by the square root of 2. I'm going to divide by the square root of 2 to get from the hypotenuse to the legs. I can, instead of dividing's hard, you can multiply by the square root of 2 over 2, and I'll get the exact same result for those legs. So that is absolutely shortcut, and I'm not going to judge you if you use it. Okay. I think it's actually a really valid option. Okay, so let's look at these next couple questions. It's quite a bit of practice that we can get. So if you want to work on the ratios, a lot of people who like to do step-by-step, they really like this method. This is the method we use when we teach regular geometry, is to say, okay, what are the ratios for an isosceles right triangle? The legs are the same size. Okay, so we say S, or pick a variable, be like, this is the small side. Okay, so the legs are the small side. So they'll be S, and the hypotenuse will be the long side, would be S times the square root of 2. Okay, again, if you times S, a number by the square root of 2, it'd be like a 1 point stuff. So if you times the value by a number bigger than 1, it'll make that value bigger. Okay, so the legs are smaller. Those are 1S and 1S, and the square root of 2 times S. Okay, so square root of 2 times S is a little bit bigger than just plain 1S. And so one way to do this, okay, very straightforward step-by-step way, is to say, I don't want to memorize any formulas. I just want to put on the ratios and say, okay, if I have an isosceles right triangle, then we know that the legs are S, pardon me, the legs are going to be S, and S root 2. Okay, and so what you look at is like, okay, which one do we have the number for? We have the number for 5 is equal to S. Okay, sometimes you have to solve an equation to find the value of S and then use it to find the other two sides. In this case, we know S is 5. And so this side is 5. So is S. S is equal to 5. So that means this side is also 5, which we know. Okay, and then this number would be whatever S is times the square root of 2, or 5 root 2. Okay, so those would be the values for that problem. On the next one, okay, we know this is S, and this is equal to S root 2. And so, I mean, you can probably look at it and be like, okay, well, I can solve that equation, divide both sides by the square root of 2, and you get 7 equals s. So that means this side is 7, and so is this side equal to 7. Okay, and this side up here stays 7 root 2. Okay, so, and that makes sense. The legs are 7, and the hypotenuse is 7 root 2. And if you need to use it on some things, but not on every problem, that's completely fine. So in this one, the legs are s, and s root 3, or s root 2, sorry. And so if we have to say, okay, so we know that this is s is equal to 4 root 3. So that means this side is also equal to 4 root 3. And then the hypotenuse would be whatever s is, which is 4 root 3. And you times it by the square root of 2, which we know. If we know the leg length, we multiply by the square root of 2 to get to the hypotenuse. So it'd be 4 root 6. Okay, and so that would be the length of this hypotenuse. Okay, so we're kind of practicing. Can you use a formula, or can you just kind of know things? A combination is completely fine. So this, in this question right here, the 2 legs are s. The hypotenuse is s root 2. And so we've got to solve this equation to figure out what are those legs. Okay, we're going to end up dividing both sides by the square root of 2. Because again, to divide to get to the shorter length, we're going to divide both sides by the square root of 2. So 17 over the square root of 2. Let's rationalize it. Get 17 root 2 over 2. And that will be the length of s. That will be the length of each of these smaller sides. And you can write it twice if you want to. It'll be 17 root 2. And that's an ugly number. You're like, oh, really? Yeah. Okay, let's try a couple more. If FE is 6, okay, then what would be EG? Okay, well, the truth is, if it's isosceles, you know these two sides are the same, and the hypotenuse is the length of those sides times the square root of 2. So this is s, this is s, this is s root 2. Well, it'll just take 6 times the square root of 2. So 6 root 2. You could have done that by doing the Pythagorean theorem as well. So EG would be 6 root 2. Okay, let's look at this. If FE is 3 root 6, well, that means this is 3 root 6. Why? Because they're both, it's isosceles. They're both s. Okay, so this is s and this is s. This is s root 2. So to find the length of the hypotenuse, you take the length of the sides, whether it's naughty or nice. Okay, we're going to take 3 root 6 and we're going to times it by the square root of 2. You get 3 root 12, square root of 4, square root of 3. So it'd be 6 root 3. Okay, and so that would be the hypotenuse. So again, the sides are both s, and the hypotenuse would be s times the square root of 2. And so use your ratios as you need to find the missing parts. So let's go over here. Oopsie. Couple more practice questions. If EG is 5 root 2, okay, let's write the ratios. If this is s, and this is equal to s root 2. If you want to divide both sides by the square root of 2, you get s equals 5. So that means this side over here is 5, and this side is 5 as well. And this stays 5 root 2. So you probably didn't need to use the ratios to find those, but if you did, you're welcome to. EG is 12, so let's find the missing sides. So if this is s, and this is s, and this equals s root 2, you got to solve that equation to figure out what s is so you can find the missing sides. So we're going to take 12 equals s root 2, divide both sides by the square root of 2. Dun, dun, dun. So 12 over the square root of 2, rationalize it by timesing top and bottom by the square root of 2. You get 12 root 2 over 2, reduce this, you get 6 root 2. So this side is 6 root 2, and so is this side 6 root 2. Now, if you want to check yourself and be like, is this true? If you take this leg and times it by the square root of 2, you're really going to get 12 as an answer. Okay, so the relationship is holding. Okay, if this is 100, find the missing sides. Okay, if this is s, and this is s, this is s root 2, we got to solve 100 equals s root 2. Divide both sides by the square root of 2. And rationalize it. Okay, so s is equal to 100 root 2 over 2, or 50 root 2. And each of these sides would be 50 root 2. And this remains 100. Okay, let's try the next one. Okay, if I've got this side is going to be 3 square root of 2, so that's s. This will be the same length. This is 3 root 2. The hypotenuse is equal to s root 2. So if s is 3 root 2, okay, you're going to take 3 root 2, times it by the square root of 2, and you get 3 root 4, or 3 times 2, which is going to be 6. So these sides remain 3 root 2, and the hypotenuse is going to be longer, which is going to be 6. So you can look at the legs and just times by the square root of 2 because you know how to do that, or you can write the ratios and just do it. Okay. The last one we're talking about, the perimeter of the square is going to be, if the diagonal is 20 root 2. Okay. If the diagonal is 20 root 2, well, you know the two sides have to be 20. Okay. How do we know that? Well, if this is s, and this is s, and this is s root 2, you can solve 20 root 2 equals s root 2. How do you solve for s? Divide both sides by the square root of 2. S is equal to 20. So that means each of those sides is 20. So that means the perimeter is going to be 20 times 4, or 80 units around it. Okay. All right. Well, thank you. Have a good day.